Good day. We are Group 7 and we are here to discuss one of the most notable personality of the modern ages, Sir Isaac Newton. We will be discussing all about Isaac Newton, his law of universal gravitation, and laws of motion. Let's first dig into who is Sir Isaac Newton. He was born on Christmas Day on December 25, 1642 and dies on March 21, 1727. He was given birth at his mother's farmhouse in Woolsthorpe, England. Sa una pa lang, he had his struggles na. He was prematurely born and barely survived. His father was Isaac Newton Sr., making him Isaac Newton Jr. His father was a wealthy, uneducated farmer who died several months before his birth. Meanwhile, on the other hand naman, his mother, Hannah Askew, remarried a well-to-do minister, Barnabas Smith, when Newton was only 3 years old. She lived with her new husband, leaving the young Newton with his maternal grandmother. Miss Hannah Askew and 12-year-old Newton reunited after Barnabas Smith died, and she even brought along her new 3 children. Isaac Newton had a rough start in life. It was also the same in his education. At first, Newton didn't excel in school. He even had interrupted attendance at a grammar school at Lincolnshire, England. But he still managed to earn the opportunity to attend Trinity College in Cambridge, where he wanted to study law in 1661. As his mother refused to support his education, he worked as a servant to pay with his own hard-earned money. Surprisingly, Newton was a working student. Newton also kept a journal wherein he expressed his ideas in various topics he was interested in. One of the subjects he immersed himself is mathematics. He became interested in it after buying a book at a fair and not understanding the math concepts the book contains. He also had great interest in Aristotle's work and expanded his theories and learned all about it. After all that hard work, by 1665, Newton successfully graduated college with a bachelor's degree. A plague even came in before he took a fellowship in 1666, which helped him obtain a master's degree. He was a well-known English physicist and mathematician, as he was the culminating figure of the scientific revolution of the 17th century. He was also widely known for his published work Philosophia Naturalis Principia Mathematica or Principia in 1687, 22 years after he graduated. He discovered and studied about optics, calculus, law of universal gravitation, and laws of motion. Optics was the discovery of the composition of white light, integrated the phenomena of colors into the science of light, and laid the foundation for modern physics. He was also the original discoverer of the infinitesimal calculus. Of course, we have his laws of motion in 1678 that introduced the 3 laws that describe the motion of an object and its relation with the acting force that soon led to the development of Newton's theory about planetary motion. Lastly, and most importantly, the law of universal gravitation. In 17th century, astronomers realized that Earth was a planet and not the fixed center of the universe and revolves around the sun like any other planet. In formulating this laws, he had a lot of questions which led to one answer: gravity.
So before natin pag-usapan kung ano ang law of universal gravitation, alamin muna natin kung ano ang gravitational force. The gravitational force or the force of gravity pulls object with mass not equal to 0 towards each other. So ito ang puwersang naghihila sa isang bagay na mayroong mass papunta sa isa pang bagay. Halimbawa na lang dito ang paglaglag ng isang mansanas o ng apple sa Earth. Sa tingin nyo, based sa example, which among the two, the Earth and the apple accelerates more? Gaya ng sabi sa second law ni Sir Isaac Newton, an object's acceleration is inversely proportional to its mass, meaning the larger the mass of an object, the less its acceleration. Based from my example, it is obvious naman that the mass of the Earth is greater than the apple, so it concludes na the apple accelerates more than the Earth or the apple accelerates towards the Earth. The law of universal gravitation. It states here that the law states that every object in the universe attracts every other object with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So yun, sa paglaki ng product ng masses of the two objects, lalaki din ang gravitational force. Pero sa paglaki ng square ng distance ng two objects or sa paglawak ng kanilang distansya, liliit ang gravitational force. So, this is the law of universal gravitation in symbols. On the other equation or symbol, we can see that there is a capital letter G. It is the constant proportionality and is called the universal gravitational constant. So the gravitational constant is equal to 6.7 times 10 raised to negative 11 Newton meter squared per kilogram squared. It is found out by Lord Henry Cavendish, and Lord Henry Cavendish did not directly measure the gravitational constant. Instead, he used the torsion balance to measure the density of the Earth. The planets remain in their orbits due to the attraction force that exists between all masses. The Earth does not move fast enough to escape the Sun's pull completely, so it orbits at a distance relative to the magnitude of the gravitational force and velocity it moves at. The planets remain in their orbits due to the attraction force that exists between all masses. The Earth does not move fast enough to escape the Sun's pull completely, so it orbits at a distance relative to the magnitude of the gravitational force and velocity it moves at. Meaning, ang ating planeta, pati na rin ibang mga planeta, ay umiikot or nag-orbit sa Sun dahil na rin sa lakas ng gravitational force nito. Pero, gumagalaw daw ang Earth perpendicularly na mabilisan kaya hindi ito direktang nahihilan ng Sun. Ang Kepler's Law and Newton's Law ay pinapakita na ang forces na humahawak sa mga planeta sa sari-sarili nilang orbit ay patuloy-tuloy na binabago ang bilis ng planeta upang sumunod ito sa isang elliptical o pabilog na path na nakadirekta patungo sa Sun.
On this part, I will be discussing the Newton's law of motion. But let us define first what is motion. Motion is the action in which an object changes its position. So Newton's law of motions are three basic laws of classical mechanics that describe the relationship between the motion of an object and the forces acting on it. So Newton's law of motion has three laws. First is the law of inertia, second is the law of acceleration, and third is the law of interaction. So I will be discussing the first law of motion, which is also called the law of inertia. Law of inertia states that an object at rest remains at rest and an object in motion remains in motion at constant speed in a straight line unless acted on by an unbalanced force. So inertia is the tendency to resist changes in a state of motion. If all the external forces cancel each other out, then there is no net force acting on the object. An object at rest will remain at rest unless unbalanced force acted on it. So hindi gagalaw ang isang bagay hanggang walang force na magpapagalaw dito. If there is no net force acting on the object, then the object will maintain a constant velocity. An object in motion continues in motion with the same speed and in the same direction unless acted by an unbalanced force. So, hindi titigil ang isang bagay hanggang walang friction na makapagpapahinto dito. So, an example of law of inertia is a man riding on a bus. So, a more massive object has a greater tendency to resist changes in its state of motion and therefore a higher inertia. But this also depends on the force acted on upon. So the man on the left side of the bus is moving with uniform motion in a straight line and the passenger has the same motion. On the right, when the bus stops, the lower part of the body in contact with bus stops. So when the bus driver brakes suddenly, the lower part of the passenger body, which is in contact with the bus, comes to rest as the bus comes to rest. But the upper part of the passenger body continues to move forward due to the inertia of motion. This explains the law of inertia. A sudden brake makes the man fall in forward direction.
Now, let's talk about Newton's second law of motion, which is the law of acceleration. Law of acceleration is directly proportional to the net force acting on the object and inversely proportional to its mass. The greater the force of light, the greater its acceleration. The heavier the object, the slower its acceleration. The law essentially explains how the velocity of an object changes when it is subjected to an external force. If you apply a force to an object, it will accelerate in the direction of that force. The greater the force, the greater the acceleration, and the greater the mass, the smaller the acceleration. There are two formula, which is F equals m times A and A equals F over m, where F is the force applied to the object, m is the mass of the object, and A is the acceleration produced. So, acceleration depends on mass. Consider two objects of different masses, say a lightweight ball and a heavy rock. If you apply the same force to both objects, the acceleration will be greater for the lighter ball and smaller for the heavy rock. This is because acceleration is inversely proportional to mass according to Newton's second law. Acceleration depends on force. Imagine a car and a bicycle both starting from rest. If you apply a greater force to the car's accelerator pedal compared to the force applied to the bicycle's pedals, the car will experience a higher acceleration. This demonstrates that acceleration is directly proportional to force given a constant mass. Acceleration in gravity. Consider dropping two objects of different masses from the same height. Both objects experience the same gravitational acceleration, approximately 9.8 meters per second on the surface of the Earth. The mass of the object does not affect its acceleration due to gravity, as all objects in free fall near the Earth experience the same gravitational field. So, the perfect example of our law of acceleration is this. Riding your bicycle is a good example of this law of motion at work. Your bicycle is the mass, your leg muscle pushing on the pedals of your bicycle is the force. When you push on the pedals, your bicycle accelerates. You are increasing the speed of the bicycle by applying force to the pedals.
Now let's proceed with the third law of motion, the law of interaction, that also called the law of action and reaction. But before that, what is interaction? In physics, interaction is the effect through which there is an exertion of force that one object influences on another. The third law states that when the first object exerts a force on a second object, the second will exert the same force on the first but in the opposite direction. Dito napapasok ang action at reaction force, na kung saan ang action force ang nag-a-apply ng force sa isang bagay at ang reaction force naman ay nagmula sa bagay na binigyan ng force. For example, when you sit on a chair, your body exerts a downward force on the chair and the chair exerts an upward force on your body, just like the picture on the right side. Makikita nyo doon yung arrow na pababa na sumisimbolo sa force ng katawan at arrow na pataas na sumisimbolo naman sa force ng upuan. There are two forces resulting from this interaction. A force on the chair na kung saan ito ang reaction force at ang force sa katawan naman ay ang action force. Sa madaling sabi, for every action, there is an equal and opposite reaction. In every interaction, two forces act on two interacting objects. And that would be the end of our lesson.